Good morning to all the examiners. I'm Teo Wen Long. Today I'm going to discuss about my FYP YY presentation topic of news event prediction using causality approach on South China Sea conflict. For this project, my supervisor is Dr. Anazita binti Zainab. So let me introduce a bit about this topic. The South China Sea is a conflict zone whereby an estimate 5 USD trillion worth of raw product ships through the shipping lanes in South China Sea each year. And then the nearby country will conflict over each other to have the main control of the whole South China Sea. Second, the event prediction is a data analytic technique that makes use of the experience and knowledge and pattern from the past to predict the future events. So the example here is the natural disaster. And then causality also the important element in this study also. So the causality is the relationship between cause and effect. And then, for example, every event will occur first on the cause, followed by the effects. So event prediction is necessary, and then the causality should be taken as the main attributes. Using these two attributes, we can perform in a news event prediction on South China Sea dispute, which is regarding to the national security. So here is the problem statement. First, the South China Sea dispute is greatly impact on the policy that made by the government, especially our government of Malaysia, to overcome the negative impacts of the SCS territory dispute in terms of national securities. So the problem in this study is that first to extract the valuable information from the South China Sea conflict news, and then the second is the challenge in understanding the unstructured online news and extract the correct information from the online news article. Third is the event prediction is biased to measure. So a good predictor is needed in this study to make sure that the prediction is accurate and precise. So here comes the research question. So the first one is how to obtain the useful information from news article that related to South China Sea conflict. The second one is which sentence representation algorithm is suitable to represent the causal events. Third is to how to use the extract information to train and build a prediction model. So here comes the objective that match to the research question. So the first one is to extract the cause effect causality pair by using the causality connector. The second one is to evaluate the sentence representation techniques by comparing the sentence similarities between input cause phrase and then with the predefined cause effect causality pairs. The third one is to develop a prediction model based on most suitable sentence representation technique. Here is the scope. The scope is only focused on the news article that related to South China Sea conflict only. So how are we going to do that is that we take the keywords that is related to South China Sea such as China, US, and then conflict, securities, and so on. And then the causality connectors also we only cover some of it, which is because of, because, after, and due to. And then this study only covered three sentence representation technique, which is dot to web, infer send, and bird, which is popular use and state of arts technique. And then the fifth is the prediction model is only based on the sentence similarity for the most possible causality outputs event. Now is some of the literature review that will be used in this study. So the first is event prediction. Why we do event prediction is that because it is wide in research. So for example, in natural disasters such as earthquake and tsunami, for political such as election prediction, social is that we can predict the protest event in Argentina. For the economists also we can predict the market stock price. uh, Market stock price. So the second one is the South China Sea conflict. We study on South China Sea conflict because it is related to our national securities. And then South China Sea is also located strategically within Asia, which involve in Malaysia. And then is the busiest shipping lane, as one third of the world shipping pass through the South China Sea, and then almost 3.37 trillion global trade happened within South China Sea in years 2016. And then due to these huge market profits, many countries are claims that South China Sea is their own territory. So for example, China have their own claim 9 dash lines, which will be discussed later. So for every dispute, all the event will be published publicly on the newspaper, which we can take this event from the newspaper. So this is the pictures of South China Sea. So as you can see, Malaysia is involved in the South China Sea, and then this is the 9 dash line claimed by China. So as you can see, this huge area claimed by China is monopolize all the shipping lanes on the South China Sea, which is dangerous to the nearby country. So now to the event relation. So for the event relation, we have two types. One is temporal and one is causality. We choose causality because it is most general to see, and then there will be a cause and to the effects. To for the causal detection, we use causal keywords, which is because, since, increase, due to, and then the extraction tools, we will use the break annotation tools. For the event representations, in this study we will consider the sentence embedding techniques, which is dog to wag, inference, and birds. The sentence representation is a distributed representation of word or sentence in vector space. Means that we represent all the sentence in the vector so that can understood by the machines, and then we can perform any task that we want. So dog to wax is actually similar to word to wax. Uh, Means that all the words are represent in a vectors, and then we add on a paragraph IDs to all the sentence, and then we take the average of the vectors, and then we classify it to have the generalized sentence vectors. So here's come two methods in dog to H, which is distributed memory DM, and then is the other one is distributed back of words DBOW. For InfoSend also, it is a state of art embedding proposed by Facebook researcher. So in InfoSend, it provides a semantic sentence representation that train on natural language inference. So this is the general idea on NLI. So consider that we input two sentences, and then the we takes the average of the sentence, and then we embed it into deep learning full connected layer, and then we apply a softmax, which is a optimizing algorithm. So in the inference, there's many components. So first is the NLI training scheme, second is an LSTM, the third is a self-attentive network, and also a hierarchical conversation network. So the third one is BERT. BERT is stand to bidirectional encoder representation from transformer, which is another state-of-art sentence embedding technique that proposed by Google AI language. In BERT, there's two important elements, which is mask LM, and then the second one is next sentence prediction, NSP. So the mask LM will provide the LM token that allows the bidirectional training, where the model can use the context words around the mask. Then the next sentence prediction is that the CLS token is inserted at the beginning of the sentence, and then the SEP is at the end of the sentence, so that whenever the sentence is connected to the SEP or CLS, then the sentence will be predicted. And the measurement, we will take the vector similarity. So there's many vector similarities such as cosine similarity, Euclidean distance, Jacquard distance, and Wurtz mover distance. And then we will take the cosine similarity because it is best fit, and then its simplicity, and it had a strong baseline. And this technique is widely used in question answering system that return the highest similarity question that link to the corresponding answer. So here is the illustration of the cosine similarity, and this is the equation that we will be used in this research. So the research methodology, in general, the research framework will be separate into three phases. The first phase is we develop a causality data corpus in the form of cause and effect, and then the second is we do the phrase representation and then the phrase similarity measure, which we will train the model and then we represent the model, represent the corpus into vector, and then we will measure their similarity. And then the third one is to we build a causality prediction model based on the best 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 embedding technique with the highest accuracy. Yeah, and then this is the overall research plan. Basically, the overall research plan is that all the research objective is matched with the research question and then overcome by all the possible methodology and solutions, and then also listed with the results. For the data set we mentioned earlier, we take the keywords such as China, Vietnam, South China Sea, and securities. So this is the pictures that illustrate we we crawl the data from online. So we after crawling all the related keyword, we actually manually evaluate whether the news is related to South China Sea conflict. So in this study, is total 200 articles are extracted. For the performance measure, we take two of the criteria. First is the ground truth labeling, which which is the binary measurement, and 0 is represent wrongly predicted, 1 is correctly predicted. And the accuracy will be based on the ground truth labeling, which is the total number of correct predicted effects divided by the total number of effects times 100. So we get a percentage. And then the embedding technique with highest is selected to be the best fit embedding for the causal prediction model. The research design and implementation. So as I mentioned earlier, we have three phases and each phase will do their own task. So this is the causal annotation. So we actually annotate one by one using this is the causal keyword after, and then by using this word we actually label the cause and effect. So after we annotate all the cause and effect, we will get this format, this called ANN format, and then this ANN format will further extract to be the cause effect tuple. So this is the work to make model training. As you can see, we set this is the learning rate, and then this is the epoch. So epoch is the frequency that we actually train the data to fit the model. So this is the InfraSend model training. So this is the baseline parameter that train the model, and then we actually input our corpus to get the vocabulary, and then we get their own unique vector. So the bird for the bird model training actually is relatively simple. We just load the pre-trained data and then we encode the corpus to get the unique vectors. For the similarity also, we take the cosine similarity. So we return the most top similar sentence or phrase that we selected. So the result is that for the first objective to extract the causality pairs, as I mentioned earlier, all the cause effect pair is annotated, and then this is extracted on the tuple. And then the second, to compare all the sentence representation. So this is all the sentence representation. So as you can see, dog to wet have 20 dimension, and then infant send has 4096 dimension. So you see the dot here, and then the bird to wag is 768 dimension. So here is the example of the output. So as you can see, this is the input, one the fish and turtle, and then we find the most similar phrase. So this is the most similar phrase, and then each of the cause phrase will link to their corresponding effect phrase. So as you can see, this is the original input, and then this is the linked output, and then this is the predicted output. So from the result previously, we do the ground truth labeling, and 0 is wrongly predicted, 1 is correctly predicted. So as you can see, bird have the most highest correctly predicted on test case 1, test set 1, test set 2, and then SAM EWA 2010 task 8. And then here is the accuracy based on the ground truth labeling. So as you can see, bird is actually have the highest average accuracy among 3 test cases, which is 50.85. So the objective 3 is we want to develop a prediction model based on the most suitable sentence representation technique. So as we taken from the previous bird, we actually built the prediction model based on this one. So for the user to input their random cost, they will output with the suitable answer. For example, like China won the trade war, so the global security governments has suffered a setback. So it's actually quite accurate to the input, and then this proven that the research works. So as conclusion, we have achieved the several achievements, such as we extract the cause effect format causality pair, and then we compare the word dog to wag, inverse and bird in terms of phrase similarity towards the South China Sea conflict related news, and then we obtain the best fit embedding technique for causal prediction model, and then we also build and visualize the causal prediction, which is based on the selected the bird and embedding technique, which return the user with the most possible predicted effect phrase. Here is some constraint. So due to the short time frame, only 153 causality pair is used, and then this might not sufficient to provide more data for accurate output. And then also the there are some ambiguous in the causal cube, which some phrase is rarely express their causation, and then the ground truth labeling may not be true, and then there's an incorrectness in the annotation of cause phrase and effect phrase, and also the causal prediction and also had limited reference resources. So for the current stage, all the researchers are more focused on solving the causal detection and causal extraction on deep learning and then the other frameworks. For the suggestions, I will suggest that maybe for the future, the other researchers can input more causal pairs to improve the quality of the data corpus, and then maybe they can improve the causality detection and extraction. So for example, currently the state-of-art methods is the self-attention network and the bidirectional LSTM to capture more semantic features for the similarities, for the phrase similarities, and then also apply a ranking criteria to make the machine self-learn for the more accurate and correct output. So thank you for listening.